Hello students, so let us start the derivation of center of gravity for the rectangular and triangular laminas. First of all, we will derive the formula for the center of gravity of rectangular element. Let us check the center of gravity for the rectangle. Here you can see what is our target to calculate the centroid of rectangular lamina using first principle. First principle is the method of integration. Okay, so you can also say like that it is the method of integration. This is the figure and calculation. Let us start with the figure first. Now, as you can see what is given in the figure, let us first check the figure. Here it is a rectangular strip or rectangular lamina for which we have to find center of gravity. Now to calculate the center of gravity, we will take some imagination, like what is given in the figure. We have to take this small rectangular vertical strip if we want to calculate x bar only. Okay, so this is must. If we want to calculate x bar, then we have to take vertical strip. If we want to take y bar, then we will take horizontal strip. Okay, remember this. If it is x bar, then strip may be vertical. If it is y bar, then strip must be horizontal. Okay, so here I want to calculate x bar, so I have taken the strip as a vertical. Okay, now what is some other distances? You can see this is the distance x from y-axis, horizontal distance x of the strip from y-axis. So remember the symbol first. X means distance from y-axis to the strip. Now what is this b? This b is the total width of the rectangle. Okay, total width of the rectangle. What is this d? D means total depth of the rectangle, total vertical depth of the rectangle. And what is this dx? So dx means horizontal, this horizontal width of the strip. Okay, so you must remember this symbols. What we have to calculate? We have to calculate x bar and we have to calculate y bar for the given strip. Okay, so again I am repeating the symbols. You just concentrate on these symbols. Okay, I am repeating one by one again. What is b? B is the total width of the rectangle. What is d? D is the total depth of the rectangle. What is x? X is the distance of strip from vertical y-axis. What is dx? Dx is the horizontal width of the strip. So these are the symbols which we will use in our calculations. So first of all, let us check the standard formula to finding x bar. It is integration of x dA upon integration of dA, where b is the width and d is the depth of the rectangle. Now in this formula, what is x actually? So as I told you, x is equal to horizontal distance. This horizontal distance x from the strip to the y-axis. Okay, now what is the formula? What is dA in the formula? What is this dA in the formula? So dA is equal to area of this particular strip. You can see in the figure, area of this particular strip, we will take it as dA. Now what is the area of the strip from the figure? From the figure you can see here the height of the strip will be is equal to d itself, and width of the strip is equal to dx given over here. So area of the strip will be is equal to d into dx. D into dx. D means depth, dx means width. So it will be the area dA. So here you can write like this: dA is equal to area of the strip, which is given by d into dx, which is the horizontal width of the strip. So now this is the initialization of the figure. Now let us calculate the y bar and x bar. See, as I told you, here it is dA is equal to d into dx for the area of the strip. Now we have to calculate x bar. For that, we have to integrate the same formula from 0 to b. Why it is from 0 to b? The strip is vertical. The strip is vertical, which will be moving from y-axis up to the width of the rectangle. Okay, again repeating, which will be moving from y-axis up to width of the rectangle. Y-axis means what? 0, and width means what? B. So integration will be in respect to 0 to b. So let us start the calculation. Integrating 0 to b, x dA. Remember the formula, integration 0 to b dA. Remember the formula again. Okay, here it is integration of x into dA. dA means area d into dx. Okay, now in the denominator again dA, which is the area of the strip, d into dx. Okay, now let us start the calculation first. Now what happens with the calculation? In this calculation, dx is the variable. You can see dx is the variable. So x will be the integrating medium. Okay, so what is the integration of x? It is x squared by 2. So here it is d constant, and integration of this x will be is equal to x squared by 2, and limit of integration from 0 to b. Similarly, in the denominator, d will be constant and integration of dx will be x. Again, the limit is 0 to b. Now, replacing the upper limit and lower limit. So, d will be constant and cancel out from numerator and denominator. What is the upper limit? It is b square by 2. So, the numerator becomes b square by 2. Same in the denominator, replacing the upper limit, it will be b minus 0. So, it will be b. Now, by simplification, you can clearly see from the numerator, one time b will be cancelled out, and final answer of x bar is equal to b by 2. So, here you can see we are using the numericals that x bar is equal to b by 2, means center of gravity of the rectangle lies at the exact midpoint of the figure. So, x bar is equal to exactly horizontal width by 2. So, x bar is equal to b by 2. Now, similarly, you can calculate the formula for y bar also. For that, you have to imagine the figure first. You can take for the y bar, this is the rectangle, original rectangle, in which you have to take horizontal strip right now. Why? Let us see. Suppose this is the horizontal strip. Okay. Now, what you have to take? You have to take this distance, means from the bottom x-axis, this is the x-axis, and this distance you have to take as y. This horizontal width of the rectangular strip will be b, total rectangular depth is d, and you have to take strip height as dy. So now what will be the area of the strip, which is known as dA. So dA will be equal to b into dy. dA will be equal to b into dy. So distance will be y and area is equal to b into dy. Now this strip, this rectangular strip is moving from bottom to top. So integration will be from 0 to d. So by replacing the same formula, you can see over here y bar is equal to integration yda upon integration dA, where y is equal to this distance and where dA is equal to area of this rectangular strip. So by replacing the value, y will be as it is, integration will be from 0 to d, and area will be b into dy. Similarly, in the denominator, area will be b into dy, integration from 0 to d. By doing the same simplification, you will get the answer of y bar is equal to b by 2. It's now very easy and repeated as earlier. So here are the final coordinates of center of gravity. X bar is equal to b by 2 and y bar is equal to d by 2. So that is the formula for center of rectangle, means center of gravity of the rectangle lies exactly at the midpoint of the figure. X bar is equal to b by 2 and y bar is equal to d by 2. So Very easy calculation for the rectangular part. Now, for the triangular lamina, it will be tough. Let us see. Now we have to calculate center of triangular lamina using first principle, means integration method. Let us concentrate on the figure first. Okay, so here it is the figure. Now you can see in the figure there is a triangular plate. There is a triangular plate like this. You can clearly see it from the figure. Now what are the dimensions? What are the dimensions? Concentrate on the dimensions. Here the width of triangle, or you can say base of the triangle, is B and height of the triangle is H. Now as you have to find y bar, vertical, y bar, then you have to take the strip horizontal. So consider this strip approximately horizontal itself. Okay, this strip is horizontal and it is a rectangular strip. Okay, you have to imagine as a rectangular strip. Now what is the width of the strip? It is B1, and what is the height of the strip? It is dy. So these are the symbols you have to take compulsorily as B1 and dy. B1 means width of the strip and dy means height of the strip. Okay, name of the strip is given as capital AB. Now what is the area of the strip from the figure? You can say it is B1 into dy. But B1, now most important thing is that B1 is variable. Why B1 is variable? Tell me, why B1 is variable? Here strip AB is taken over here. What happens if strip AB is taken somewhere over here? Then B1 will be increasing. You can see this B1 strip width will be increasing. What happens if you take the strip somewhere over here? Then B1 will be decreasing. It means what? Strip width B1 is variable. So this is not valid. So first of all, we have to fix the value of B1 first. Let us check how. Here some notations are given. B is equal to base of the triangle, H is equal to height of the triangle. Now we have to compare two triangles. Now which two triangles we have to compare? Let us check which two triangles. Concentrate on the figure. This is the upper triangle, or you can say smaller triangle. Okay, this is the smaller triangle. You can clearly see from the figure. This is the smaller triangle. So now onwards, I will call it a smaller triangle. And this one, this total is a bigger triangle. Okay, so I will call it as a big triangle. Now, as small triangle is belonging to the big triangle. Okay, small triangle is belonging to the big triangle, so it is a subset. So this type of case, in this type of case, two triangles, small triangle and big triangle, both are similar triangles. So we can take the ratios by similarities. So let us take the ratios by similarities. Then ratio of this base upon ratio of this base means B1 upon B is equal to ratio of their corresponding heights. So what is the height of this triangle? Concentrate. What is the height of this triangle? Think about it. What is the height of this triangle? It will be H minus Y. What is H? What is H? H is equal to total height of the big triangle. And what is Y? Y is a strip distance from the bottom. Strip distance from the bottom. So subtracting Y from H, you will get the height of smaller triangle. So H minus Y is the height of smaller triangle. And what is the height of bigger triangle? It will be H. You can see from the figure. Okay, now what is the main target? What is the main problem? As I said, we have to fix the value of B1. So subject, making the subject as B1, you will get from this formula B will be cross multiply in the numerator. So H minus Y upon H into B. So it is the strip width B1. Now we have to calculate a dA. What is dA? Area of the strip. So what is the area of the strip from the figure? It is B1 into dy. B1 into dy. B1, as we have find B1 into dy means H minus Y upon H into B. That is the value of B1, and dy will be as it is. So here our first target is completed, means we have calculated the value of dA. dA. Okay, now we are going to calculate y bar. What is the formula for y bar? It is integration 0 to something. Let me check about the limit afterwards. What is the standard formula for y bar? It is integration of y dA upon integration of dA. Repeating, integration y dA, integration dA. What is y? Y is the distance of strip from the bottom. Okay, what is dA? dA is equal to area of the strip in the numerator as well as in the denominator. You can see here it is the area of the strip dA. Now what is the limit of the strip? This strip, concentrate on the figure, this strip will be running from bottom to top, anywhere from bottom to top. So it will be giving limit from 0 to height, means bottom to height. Clear? So let us see the calculations now. Here it is the calculation. Standard formula is integration y dA upon integration dA. Integrating given limit 0 to h. So between 0 to h, y bar is equal to this formula. Means what? Integration limits y dA upon integration dA. You can check back and verify the value of dA. Okay, now this is very complicated calculation. Okay, this is very complicated calculations. So we will calculate numerator and denominator separately. Let us check first numerator. So what is numerator? Integration 0 to h, y, h minus y upon h, d into dy. Here dy, you can see here dy is the variable. So without y, every terms will be constant. Now replace this y in the bracket. Concentrate, repeat, this y is in the bracket, means multiply in the bracket. Let us see what happens. Okay, so here it is the calculation. You can see it is the, sorry, here it is the calculation. You can see here it is the formula of numerator. Integration 0 to h y dA. 0 to h y dA. Now what I have done? Just multiply and get the terms separate. This is the first term. Here it is minus. So this is the second term. I have multiplied y and b both in this bracket. So yh by h into b and y square by h into b dy separate terms. You can multiply y into b in the bracket and you can see this within your notebook by rough work. Now let us start the integration. As I said, b is constant, so out. 0 to h is the limit of integration. What is the variable? Only y. So h will be cancelled out and integration of y will be y square by 2, limit 0 to h. In the second term, b and h both are constants. So b by h is out. And what is integration of y square? It will be y cube by 3. Limit will be 0 to h. By replacing the upper limit, it will be h square by 2. So answer is b h square by 2. In the second term, b by h remains constant and y cube, replacing the upper limit, it will be h cube by 3. So one time h will cancel out and the simplification will become bh square by 3. And here it is first term bh square by 2. Now what is the LCM of 2 and 3? It will be 6. So by doing the simplification, you will get the answer bh square by 6. So basically, it is the simplification of numerator only. This is the numerator which will give the answer bh square by 6. So remember, this is the numerator only for y bar, bh square by 6. Now let us check the calculation for the denominator also. Here it is the calculation of denominator. What is denominator? Integration dA. Integration dA, replacing the value of dA. Now again, replace this b, means multiply this b in the bracket and get two separate terms. So it will be 0 to h, b dy. How it is b dy? When you will multiply this b inside, this h will get cut out. Only b will remain in the bracket. In the second term, it will be b into y upon h. It will be b into y upon h dy. So now by doing the calculation, y is the variable, b is the constant. So integration of dy will become y limit 0 to h. In this term, b and h both are constants, so taking out. Only remaining is y into dy, which will integrating by y square by 2 limit 0 to h. Now just replacing the upper limit, you will get b into h in the first term. And in the second term, b by h will remain constant, while integration of y square by 2 will become y cube by 3, sorry, y square by 2 as it is, and by replacing the limits, it will be h square by 2. One time h will get cut out from this, so answer will be first term bh and second term will be bh by 2. By simplification, mathematical simplification, you will get bh by 2. So remember this. This is the formula for denominator. What is in the numerator? What is in the numerator? It is bh square by 6, as we have seen earlier. And what is the simplification of denominator? It is bh by 2. Now b will be cut out, h one time cut out, and 2 3s are 6. So final answer for the y bar is h by 3. So here it is the formula of y bar, which is equal to h by 3. So now you will be clear. What is y bar? It is h by 3 from the bottom. So where is the CG of triangle? Where is the CG of triangle? It is at a distance of 1/3 of height from the base. 1/3 of height from the base, as we have taken in the numericals till now. Now the triangular figure is symmetrical about y-axis, so x bar will be directly taken as b by 2. So here is the formula for x bar and y bar of the triangular lamina. This truth here is means to calculate the center of gravity of rectangle and triangle is very much important from the subject point of view. So remember these two derivations, calculate again and again in your practice book, and we will meet in the next lecture. Till then, goodbye students. Thank you very much.